Event studies are a tool in causal inference that has a wide range of use cases. For example, when I was working for the Securities and Exchange Commission, we often used event studies to measure the impact of insider trading. Specifically, when news would come out, we would use an event study to determine if that news was material, if it had an excess impact over the normal range of returns. Event studies are also great in tech with, let's say, staggered rollouts. Let's say you are introducing a product, or you're like Uber and you're suddenly going into new cities, or Airbnb that goes into new cities one at a time. And we want to know what the impact is of this staggered rollout. So event studies are used when you have time series data. The treatment may or may not have a staggered rollout, but you can use it for them. There should be a good comparison group. And also, an important feature of the event study is that the treatment effect may change over time, and you can pick this up. In an earlier video, we talked about the interrupted time series, and we can model that with a level change and a trend change. But when you think about the implications, look at the treatment effects. When we have this level here, and then we kind of assume that the trend continues going up. But it's unlikely that an effect is just going to keep increasing in perpetuity. For example, maybe you have this marketing shock and there is an initial bump in revenue or conversions or visitors, but then the effect wears off. Event studies are great for that. So let's give an example. In this event study example, we're going to use stock returns to answer the question, did JP Morgan receive excess returns from the presidential election through Jamie Dimon's possible friendship with Trump or any other reason? We're going to start off using the Yahoo Finance API, pulling in stock market prices every day for JP Morgan, Wells Fargo, Citibank, Bank of America, USB, Berkshire, and then also the S&P 500 and a financial index. The latter two are just Vanguard ETFs. So you can see it just pulls in the prices, its dates going down the rows, and then the columns are, each one of these are the stock returns or the stock prices for those companies. And we can quickly convert those prices into a percent change. So now we have a data frame of daily percent changes for each of these banking stocks, plus in the ETFs for the S&P 500 and the financial services industry. And if we plot the returns, JP Morgan's returns are usually centered actually right around 0.1%. But then on election night, it's spiked by 11.5%, or this is actually the day after the election. So the first trading day after the election. Now, keep in mind, I am just using this as an example. There's not meant to be any politics here. We've used this in the past if there are FDA approvals or if a drug doesn't get approved by the FDA. You could also use it for, let's say, a big earnings announcement or any announcement about the company, or like CrowdStrike when they had the big the outage, like all these different things that you could use this tool for. So the first thing that we can do is just run a simple regression of JP Morgan daily returns against an indicator, a dummy variable for that event day, and a constant which will pick up the average daily return. And sure enough, you can see that the average daily return is 0.1%. And when we run the regression, that is exactly the intercept. And then the excess returns on the day is 11.4%. So 11.4 plus the 0.1, you get 11.5. Okay, but is this an excess return relative to how the banking sector and the rest of the stock market did? When we control for all these the returns of all these other companies and the indexes, we can see that this drops from 11.4% all the way down to 2.4%, though it is still statistically significant. So this would argue, even relative to the returns of these other banks and the whole stock market as a whole and all these other financial services companies, JP Morgan still had an excess return of about 2.4%. But now remember, an event study is useful for seeing how the effects possibly change over time. So let's see what happens when we add in the next couple of days. So we create dummies for the next 3 trading days, or the next 2 in addition to the day after, and we run the model again. And sure enough, we see the 2.4% on the first day. but then a drop of 1.9. Again, this is all excess relative to these other companies, and then another drop on the third day. Notably, the first 2 days have statistically significant results, but the third day is not statistically significant from zero. So I put together a function. We can plot these coefficients, and the blue are going to be the individual daily returns. The second day is way down here. And then the red is the cumulative return. And so by day two, most of that excess return is gone. And by day three, it's actually a little negative. Now, there is no obvious answer to which set of dates that you should test here. Are you only testing the first date? Would you test the first two since they are both statistically significant? Would you also add in the third just in case? You're going to have to make a defensible choice here. Now, it is common to look for possible news that was in there or to have successive days where there's statistically significant results. While in the latter case, you would want to verify that there was no other news that came out. Anyway, this is a choice that you will have to make to think about whether those first two or first three or only the first 1 day is affected by the election results or whatever event that happened. So in this case, I chose the first 2 days. And when we look to see if that cumulative effect is any different than zero, sure enough, it is nowhere close to statistically significant. And so we might put out a summary that says, even compared to these other banking companies, JP Morgan appeared to have excess returns on the first day, but it appears that they were completely mitigated and gone by the second day, or at least we cannot conclude that they were any excessive returns greater than zero when we consider the first 2 days. Now, and this is really important, but you will also have to put on your data science hat and think about the implications of what you are controlling for. So in this case, in the earlier case, you controlled for all these other competitor banks. But maybe you don't want to do that. Maybe the question isn't whether or not JP Morgan had excess returns relative to its competitors. Maybe you're interested in just the banking industry as a whole, or you just want to see how JP Morgan did relative to the market, but not necessarily relative to its peers. And so if you run the same regression that we did before, but we only control for the S&P 500 index, well, now we're right back to a much larger return of nearly 10% excess returns. And so it's going to be really careful that you think about the actual question and the implications of the model that you're actually running.